when a member is carrying compressive force along its axis is called a compression member. Column is a compression member, you know that. Next thing is, only very short column will be having yield stress. Up to yield strength it will be taking the load, then it will break. You will test either your concrete material by making small cubes. Whenever you are going for project, you will be making small cubes and it will be the same size in width as well as in depth. So you will be testing that, and whenever you are testing, the material will crush. You can squash that, but in a column, this is a long member, it will not fail like that. So it will fail due to buckling. Buckling is it will bend. If you are keep on increasing the load in the column, what will happen is it will buckle and fail. It will not yield. So yielding is first point, buckling is second point. So when you are doing test in UTM, and if you are testing for mild steel, how you are conducting a test? You are stretching the material. You are providing a mild steel, you are stretching the material and finding the yield strength. Yes or no? If yield strength is 400 or 410, how you are finding is you are stretching the material and you are finding the yield stress. Is it the same way the load is acting here in both the columns? Are you having any tensile force here? No, the column carries compression force. The beam is there, below that you have column and it carries the compression load practically. Whatever the way you test is different and what is existing is different. You are finding the yield strength. So that is why in the second point it is mentioned that very short column. You have three types of column: long column, short column and intermediate column. According to the cross section and the height, it is called slenderness ratio. If you are having slenderness ratio limit, you can classify into three types of column. If the column is failing, in short column you will be finding the yield stress. You will take up to the yield strength load. If your column is having 410 Newton per mm square of strength, it will break at 410 Newton per mm square of stress. Okay. If not, you will be not having that. For long columns, the breaking point will not occur at the yield strength, it will only buckle. So this is what which is given in second point, long column buckles. It is always subjected to buckle and fail. So instead of finding the load, if any compression load is acting in a member, how will you find the stress? Stress equals what? Load by area. You cannot use load by area for finding the stress carrying capacity in compression member. What you have to find instead of that? In compression member you have to find what? Buckling. Why? Because before crushing itself it will buckle, that is it will bend and fail. This is what you have to understand. It is here mentioned that the long column always tends to buckle, occur prior to the development of full strength of the member. Another point is, whenever you are designing a compression member, you no need to eliminate the holes whatever you are doing. Whenever you design the connections, so in connections there will be gross plate. The plate thickness is 100 mm and length is 100 mm and thickness is 10 mm in the sense, how will you find cross section? 100 into 10 and you will subtract the holes. How many number of holes are there? N into B. So how will you find area? Gross area minus N into B. What is N? Number of holes. B is breadth. In the breadth, how many holes you are providing, and the holes area will be eliminated and you will find the cross section. But in case of column, you no need to eliminate. Why? Because you are creating the hole and after that you are inserting the bolt. Yes or no? So the cross sectional area is being filled by the bolt. So no need to reduce your cross sectional area. In your design you will be not reducing the cross sectional area. This is one of the advantage. And since the bolt is replacing the holes, the whole area is often ignored. So these are the points which you have to understand before getting into the design of compression member. Types of compression member. So you would have heard number of names as compression member. One thing is column. always column is known as a compression member. And when you say it as column, let me explain. And you have another similar word called post. So you will be having lamp post, portico, you will be having a post. What is the difference between that? This is a column. In portico, if they are providing, they are saying it as post. And they are in similar area, they are calling it as strut, S-T-R-U-T. In some areas, the same column is being called as a strut. Why they are calling? There are small words and concept which differ when dealing with the compression member, and in a crane it is called as a boom. See, when you are looking into this picture, you have different type of compression member. So this is also a compression member. When you are constructing bridges, so what is this name? Pier, P-I-E-R is pier. So this is the same way, whatever your column is there, it is taking the compression load, but they are calling it as pier. Pier in the sense it will be taking large load and the dimensions will be much higher when compared to the column. Okay, then this you can call it as a column. How they are calling it as column is, the column will be transferring the load of beams, and these are all known as post. If you are placing this kind of members, these are all wooden members. This is just provided to take these small loads. So you will be not having large amount of load, only small loads will be there. That too, the member will be very short. It will be not as long as a column, it will be very short. Then it is called as a post. Now, this is a crane, you know that. In a crane you will be having this boom. You can operate this. Either you can extend your boom or you can make it elevated. The boom is also a compression member. When you are adding the load, what happens? This tends to compress this member. So this is also another type of compression member, and this is a steel structure. In the steel, you can see column will be provided at the post of truss. Below this truss, you will be having column, and the members in a truss is called the strut, S-T-R-U-T. What do you mean by strut is? Strut is a member which is available in the truss. In the truss also you are having vertical members, yes or no? The vertical members are available here also. So it is called a strut. When it carries larger load, then it is to be named as a column. Okay. Now here also you are having the number of members. So this is also a compression member. This is known as bracing. And when your member is carrying a compression member, this member is known as bracing. This, why they call it as bracing is, bracing is provided to carry lateral load. When a force is there which is occurring due to wind load, what happens? This member tries to deflect in a horizontal manner. So in order to reduce that, you are providing the member called bracing. So the bracing also can be compression or tension. So these are the different types of compression members. When you are understanding, do not understand column is only a compression member. What are the different members are there? Column, post, strut, boom, and pillars, all are compression members. You can call it with different name. They fulfill their different purpose. So understand the difference between that. This is what I said. The compression member is used for roof truss. Is called a strut. It either might be a king post truss, queen post truss. In a truss element, if you are having any compression member, it is called a strut. Note that the strut can be vertical or inclined. Always the compression member is not vertical, it can be inclined also. You saw the bracings, bracings are inclined only. The inclined members can also be a compression member. Your design can fit all these elements. If you are knowing steel, design of steel elements, and if you know to design a compression member, you can design all these members. What are the factors which differentiate the strength of a column? It depends on these following parameters. If you change the material of a column, then you can increase the strength or decrease the strength. If your column is having 300 mm by 300 mm, if you increase 300 by 450, then the strength increase. And if you reduce the dimension, it gets decreased. That is one. This is cross-sectional configuration. And if you change the material, instead of steel material, if you include fibers, carbon fibers, then you can increase the strength of the material. And if you increase, and you can try the column by natural fibers also. So it gives a different strength. So if you change the material of the column, then the strength is increased or decreased. And cross-sectional configuration. Whenever you change the cross section and the shape, you can provide the column as a circle or rectangle, or you can try with some other shapes. Hexagonal shape you can try it, or pentagonal shape. So how you try the column size, it also depends. In number of monument structures, instead of a column circular or square, you can see some person who are standing there and lifting the load. There are number of monumental structures are there. You can change the cross section also. It might be regular or irregular. If you know the concept of increasing or decreasing the strength, you can make the changes. What you have to do is, you have to check the minimum cross sectional area required, so your figure or your picture, whatever you are making, will be much higher than that. You should not reduce that and make the architectural thing. If your column length is increased, the strength decreases. If your column height is 3 meter and it is able to carry 100 kilonewton load, you cannot increase the same column for 6 meter, it will not take 100 kilonewton load. It will take much lesser than that. If you are increasing the column, the load carrying capacity will get decreased. So that is why in the last picture, see here, you can see higher cross section of the column. The column cross section is much higher, even though it might carry only the load of beam and roof. Why they are increasing the cross section is, if your column size is increased, the buckling will be very much soon. So you can try with a small stick. If your length of your stick is much higher, you can bend it easily. The same cross section only. So in case of compression member, buckling is the only phenomena, not the compression strength. So you have to find the buckling strength. So you have a formula for Euler's buckling load, pi square EI by L square. Can you remember that? So if you want to find buckling load, your formula is pi square EI by L square, not P by A. That is compression load, you can find it by P by A, or stress into area, you can find it. You cannot use stress into area, you have to use pi square EI by L square, where L is what? Length of the column, and the length of the column you cannot take exact. You have conditions for that. Can you remember? If one end is fixed and other end is free, that is one case. If your column is only fixed at one end, other end is free, this is one case. If both the ends of the column is fixed, that is another case. Whatever the happiness which you get in cricket, the football, kabaddi, the same happiness you can get in education. What the thing is, you need some time to understand. Right now you are in an adult age, but soon if you go to some ages and if you cross something, you know the beautiful things in nature. What you see beautiful now is not only the beautiful, but if you come across the life of nature, there are much more wonderful things in here to view, here to understand, which you will know after some time. The nature itself is blocking the humans. Nobody is blocking you. Nature itself will block. When I was a student, it blocked me also. Only at the certain stage it will get reopened, and your knowledge, your vision will get reopened. But in some extraordinary cases are there that everybody would be knowing that. But instead of that, majority of the people will be falling in that. So they will be attracted in certain things in the certain age. If you are a kid, you will be attracted with candies. In the age of 4 or 5, everybody will get attracted. So can you stop the kid? Can you teach the kid only one answer? If you buy that candy, that is the only answer. You cannot teach them. You cannot try to convince them. Have you convinced any kid? If he or she is asking for a candy or a chocolate, can you convince them this is not required for you? You cannot convince them. Like that, the only answer is that. Only if they cross that, now you will not be fond of that candies. So now you will be fond of pizza and the later version of that. So always you will be happy to accept biryani. Whenever biryani is there, okay. So like that, it changes. Why the thing is, whatever the thing you are getting, you will not convince with that. Slowly it will go off, but there are much more things in this world to view and to get happiness. What the thing is you are looking is, those who are outside are the only people who are happy. Right now what do you think is, those who are outside are happy, I am sad. This is your understanding. This is what I am saying, that your understanding will get extended. Okay, at that point of time you will understand these words, whatever I am saying. Yes, the support conditions at the ends are different, which is what I said. One end is fixed and other end is hinged, which is one type. So you will be using different types of L. So L equal to 2L is there. So when you will be using L equal to 2L, if one end is fixed, other end is free, in Euler's theory you will be using L square equal to 2L square. So like that it will be there. I will explain it further. So if your support condition change, then strength of the column changes. And residual stresses. If you want to do research on this topic, project on design of commercial building, design of 12-story structures, they will take wastewater, and some people will do pavement design. You can do your project only on compression member. What you have to do is find the residual stress. Your column will not be exactly in rectangle. Slight twisting is also acceptable. So how much we can accept? These things comes under perfection. The material might not be isotropic and homogeneous. You might have two or more materials, and geometric variation of column and eccentricity of load. You can assume that the column is axial, but there are practical cases the column can carry torsional force also, bending force also. Okay, these are the important parameter. If you want to increase the strength of the column, will you increase the height or decrease the height? Increase or decrease? Decrease the height. If you want to increase strength of the column, will you increase cross section or decrease cross section? Increase cross section. So this is what I am saying here. Whenever you are designing, you can find an answer that the stress carrying capacity of your column will not be enough. At that point of time, what you have to change? Either the length you can change, either the cross section you can change, or either material you can change. Instead of 410, you can use 500 Newton per mm square, like that. Without knowing this, if you are straight away jumping into design, in some cases the design might not come under the limit. At that portion, what you have to do? You have to check these conditions, and you can revise that and do the problem. You will be getting safe design. Yes, next title is possible failure modes. How the column can fail. That is, first thing is by local buckling. So this kind of failure is known as local buckling. Buckling is known as a bend. So you can see a bend here. Why they call it as, there are two types of buckling. One is local buckling and another one is global buckling. If your column is completely buckling from the top to the bottom, you can see. If it is completely buckling towards all the length, then it is called global buckling. What do you mean by local buckling is, you can see small portion of the column is only buckled, not the whole column. At only a local point it is getting buckling, hence it is called a local buckling. Buckling is known as a bend. When the load is too much high, you can see that there is buckling at this portion. So this is called buckling. A column can fail by first this process called buckling. Then second type is squashing. Squashing is what? If you are increasing the load, what happens? You can see the squash here. So if you try to squash your fruity, if you are using fruity or Tropicano like that juices, if you compress that, it will not buckle. What will happen here? It will squash. Why it is squashing? Because the length is very small. So if you are pressing it, it will squash. Why? Because it is a short column. If you make a long one and if you try to crush it, it will not squash, it will buckle, it will bend. So this is the second mode of failure called squashing. This is only possible at relatively small length. If your length is small when compared to cross section, that is short column, it is possible. How to find the load is yield stress into cross sectional area. This is the formula to find squashing load. Now, how to eliminate buckling? If you are thinking that my column should not even buckle, then what you should do is width to thickness ratio should be changed. First, if you are designing your column and it is buckling in the sense, you have to give the solution. How will you give solution? What you can change? Width to thickness ratio. You have to increase the thickness. If you increase the thickness of the member, then you can reduce the buckling. Okay, next two type of failure is flexural buckling. You can see here, there is a column which is initially straight. If a load is being applied, then it is curled. You can see the buckling here. Initially the member is straight and this is a long column too. If load is increased, you can see the type of failure is a overall flexural buckling. Always beam is a flexural member. The flexural buckling can occur in beams. This is a similar way of having the flexural buckling. In this point of time, you have to check the weaker principal axis. At which direction it will buckle, how you have to find is, find the weaker principal axis. Okay, if your column is buckling in x direction or y direction, how you can find is, if the I, that is moment of inertia, wherever portion it is less, at that axis it will buckle. If your moment of inertia is twice in x direction, it will not buckle in x direction, it will buckle in y direction. Always why in ancient monuments they have choose the circular section is the moment of inertia in Ixx pi d power 4 by 64. That is the moment of inertia formula for Ixx. What is the formula for finding moment of inertia of rectangle section? BD cube by 12. What is the formula for finding for y axis? DB cube by 12, isn't it? So the formula changes. But in a circular section for Ixx, your formula is pi d power 4 by 64. For Iyy also pi d power 4 by 64. For both the axes, you are having same moment of inertia. That is why in all the monument structures, whatever you see, it might be mosque, it might be large palace, you can see circular column. Why they prefer is, they have equal moment of inertia on all the sides. If you try to push in any direction of a circle, it provides the same resistance. So that is why they provide for a circular section. But now, why we are reducing the circular column is work. We have to do more work. It is not easy to do plastering for a circular column. Due to work and time, what they are making is, they are making a rectangular or square column. Okay. Now, you can have torsional and flexure. So, due to both the things, the column can buckle. So, this is an example for that. You can see a member, it is being twisted. So, can you observe the twist here? So, the member is twisted and it is failed. So, a member can fail due to combination of torsional and flexural buckling.